So let's move to stage 2 and let's record our decision. In stage 1, it was basically about input handling and create a very basic skeleton. In stage 2, now that we know that the input handling works, we will start rendering something on the screen. So let's create an empty level with borders, and the player can walk around within the borders. So let's not be too greedy. That should be enough for stage 2. This solution will not be perfect as we discussed before, but that's okay. So instead of just printing out the keys that were pressed, we start moving the player around in the board. Let's start writing it. Oh, before that, let's create a copy of the current code. Okay. I want to quickly move something out. Lower is better, faster. So we can adjust the speed a bit more easily. Okay. So what do we want to change? We don't want to print the keys anymore. What we want instead is something like handle player. That will get the key that was pressed. And we also need some kind of position of the player, of the player character. Let's have a starting position of 5, 5. So that is still should be close to the upper left corner. And let's pass these in. So the handle player function can update them. And we will also need a render function, which will also get these 2 positions, because nothing else actually matters. Everything else will be static, every other aspect. The borders will be static. The only thing that can move is the player character. Okay, well, before that, we actually will make a decision of how big is the level. And let's record that in code by this. So this is how big the screen is. We are not implementing scrolling, and this should fit on even a very small terminal. This X coordinate will also include the new line character, which is not visible at the end. So only 59 characters will be visible. Okay, let's implement these 2 functions now. For the handle player updating the positions, we have to be very careful to not fall off the screen. So we have to stop at the borders. We basically have to clap these coordinate changes. And for that we need a minimum maximum functions. And in order to get that in C is like this. Okay, now we really have everything, so we can start writing the functions. Let's quickly walk over it, what we are doing here. So basically, all of these functions, now 1 means that we are moving up. Moving up, if the upper left corner position is 1, 1, means that we have to decrease the y coordinate. But we have to clap it at 1. We can't go lower than 1, because then that would be we will be on the with 0 we would be on the upper border. With -1 we will fall off the screen. We don't want that. And when we are moving down, that means that we are increasing the position y, but we don't want to we don't want to move to the border. The border would be on max y -1. So we have to stay ahead of below that, above that. And the same thing here. Why we see -3 here is the reason is because we have a new line character that is not visible. That's why this is not symmetric. And -1 is the new line character, -2 is the border, So -3 is the last valid coordinate for the player character. And moving left is simple because on coordinate 1 that is valid. Coordinate 0 is the position for of the border. But apart from this code basically is just taking 1 or adding 1 to the relevant coordinate. Let's implement a very simple render function. We will print the whole level at every moment. On each tick of the game loop, we print every character, starting from the top, moving right, then the next row, moving right, and so on and so on. The most important part of the render function, which I very often forget, is to flash out, so I will all the characters in every game loop. If you forget that, then you will get really weird errors. Maybe I will show that afterwards. But now I start with that to not forget it. So this is clearing the screen. Even though we will overwrite every character on the board on the 60 by 24 characters, there could be others, some leftovers, and this line can get rid of those. Basically, we should call this only on the first render, but it's okay. We will move our cursor to the upper left corner, and it doesn't start with 0, 0, but in our code it will be 0, 0. So we have to adjust when we are talking to the terminal, like here. So in our code, our coordinate system starts at 0, but when we interact with the terminal, which will happen very rarely, basically only in this line of code, now we have to adjust it. Now this one prints out the top border. Then we will print out a new line at the end of that row. And we can repeat that again to print out the bottom border. And here we will write the rest of the rows. So these rows will start with one big X for the left part, then a lot of spaces. Sometimes in one row there will be a player where we will write out an @ sign. At the end of the row we will print again an X and a new line. So we need 2 for loops for that. So to understand this, let's take a look at the coordinates. This is which row we are standing on. So we don't care about the top borders row and the bottom borders row. So that's why it here is -1 and we start at 1. Now we can think about only about a single row. We start with an X, that's the left border, and we will end in an X and a new line. So far it's very understandable. That's why in the middle of it we will start at coordinate 1 and we will go to coordinate -2. -2 because of the new line. So these 2 characters are calculated here. So now all we need to do is that we basically always print out spaces. We just have to check whether the passed in position X or Y is the player's position now. And let's just write an if statement for that. So this should do it. Did we implement everything? So we have the handle player, which updates the position. Then we have the render function, which takes those positions, and we flash it out. Yeah, it looks okay. Let's try to compile this. Oh, sorry, you don't see it. So this was the line I sent. Oh, it looks okay. I can walk around. The upper and lower borders are okay. The bottom borders are okay. And the right borders are also okay. So we achieved what we wanted in stage 2. We can see that already. And we can already see its weakness. I don't know whether this is visible on the... I stop it. I wasn't sure whether this was visible in the video, but it was blinking a lot. And it was pretty slow. So we keep redrawing everything, and that's the terminal doesn't like it. So let's move to stage 3. Now that we finished stage 2, let's take a copy of the code we have. And let's decide what to do in stage 3. So let's in stage 3 let's optimize everything. Let's optimize the rendering. Let's prepare everything for the game logic. Optimize rendering, optimize game loop. So this is my goal, to reach a state where we can start adding some stuff, and we don't have to deal with these things anymore. I don't want to keep refactoring the game engine code while I'm adding game logic. Okay, let's start. So what's the idea? How can we optimize rendering? Currently, we are on every render step we clear this whole screen and then print out the whole board. Now, of course, just removing this from here, because this was actually a mistake that I put it here, and just clear the screen here is a good first step. That will already get rid of at least half the screen will be not written anymore. But the idea is to update only those pixels, big pixels, characters that changed from the previous loop. Most of them will not change. How can we achieve that? Is that we will keep 2 buffers for the screen, for the state of the screen, and we will update one of the current screen and make changes there, like the player moved, so we will update the player's position there. And during the render thread, the render will just take a diff and update those characters on the screen that are different between these two, and then we flip. So that's the main idea. I want to keep the render very stupid. It should just get a buffer and the old buffer and the new buffer and write out the diffs, and nothing else. It should not have these kinds of code that currently it has. And what about the game loop? I want the game loop to look something like this. That read input, update, render. I want to see these 3. And I don't want to pass random variables around, so they should just get some kind of state here. That's the main idea. So let's start fleshing it out. Obviously, this means that we have to touch nearly every function we already wrote. But after this, we will have a much cleaner, nicer state. Probably let's start with defining a struct for the game state, to not have to randomly add the various variables. So let's call this struct game state. It has a few things: a key, that the current key that was pressed, which most of the time it's nothing was pressed, the player's position, and the 2 buffers I was talking about. These are multidimensional arrays, card arrays. We add the y coordinate first and then the x coordinate because how it is laid out in memory. This is a contiguous buffer in memory. This will be easier to understand when we when we will create maybe some tests. So for example, this can look like this. So this was row 1, this was row 2. This is how this looks like in memory. And we can simply initialize it like this if we want to. Let's clear the screen here. So the update method is the first one that is called during the game loop. We take the copy of the old screen that was the that was the end state at the previous loop, and then we will make some adjustment. The only adjustment at this moment we can do is whether the player moves. So let's move the handle player into the update function. Now we have to update the handle player. Instead of using these that takes account only the borders, we will actually start using the state screen variable that stores what is there. So instead of this, we are actually getting every state from the game state parameter. So what do we have to do? This checks whether we are near the border, and so this means that we will move. We have to clear the existing space where we were with a space character, and we have to add the add sign at the place where we moved. And we also have to update the player position, so we don't have to look it up every time. So this is the coordinate of the previous position of the player, which we now clear. And then at the new place, we put the player. And similarly, we can update the other parts. Okay, let's change the render function. This is basically, we can throw away everything here. As I said, we want to keep this render method very dumb. So we go over the whole board from 0 till the end, including the new line, and then we implemented this optimization. So if the old screen's coordinate at that given position is different than the screen's position, so it changed since the last loop, that's the only moment we will do anything. And then this means that we move the cursor to that right place, and then we will print out what's in the screen at that moment. And that's it, and then we flash it out. The render should be done. I think we have nearly everything. Yes, we have to update the input reader. And we have to create the state somewhere. So currently, both the screen and the old screen is just empty. It's full of zeros. And that's not okay. We still need a moment where we create the initial state. Let's call this setup board. So we do this outside the loop. So we need to update still the input reader to use the game state, and we have to create the setup board method. Okay, this finishes the read input, and now let's create the initial board. So this way we set up, instead of zeros, it will have spaces, only the screen coordinate. Then we will add the borders and add the initial player position. But we can do this much simpler now than before, because we are not printing to the screen. We can refer directly to the screen coordinates. So these two created the top border and the border at the bottom. So what's left are the left side, right side, and also don't forget about the new lines. So these were the left side and the right side, and now the new lines. This is the initial player's position, and let's render it here. Otherwise, in the next step, when we enter the game loop, let's take a look at that. So when we enter the game loop here, we will, in the update step, we will actually clear this, because what does the update do? It immediately copies the old screen, which is still full of zeros, to the screen. So here in setup board, we will set it up literally the terminal's screen by calling render first. Oh, we don't need this at all anymore. Yeah, I just wrote pseudocode here. Okay. I have probably had everything. Okay, I still can't fall off the board. The screen was still printed. It is not blinking to me. Okay, it looks okay. Ah, well, now this is ugly. Let's fix this one, and also I will introduce another optimization for the game loop. So in order to fix that we will not end up in the middle of the screen when we exit the code, we will do a simple optimization. So basically, I move in coordinates below the board and print a new line. This can be looked at as a trick, but I think this is pretty nice. I want to put strings below the board anyway. So even during the play, we could later show the amount of gems we collected mid-game, and also we will write out that you won the game or you died. And this is just making space for that, and why not use this also for the exit. So that gets rid of that. Now for the other change I want to make, and then we will close this stage, is that let's imagine that we always sleep the exact same amount, regardless of how many work we did before. You can imagine that this work takes a variable amount of time. So an optimization for this is that we will record a start time here, and then we will, after everything was done, we will record an end time here. And then we will look at the difference and measure how much time it took, and decrease the amount of time we sleep here by the time that was the time it took to actually update and render the screen. Okay, this is just the implementation what I was talking about. So this is how much time it took. If in some cases, if that happens, that we actually, this took longer than our intended game loop sleep, then we don't sleep at all. We move immediately to the next loop. Otherwise, we will just adjust the amount of time we sleep. I forgot a very important thing. So this code actually has a bug during the rendering, but it is due to lucky circumstances. It is we can see that bug actually. So I forgot one thing, to actually flip, to save the old screen. So let's do that quickly. So this is pretty important, that before the end of the loop, we save the as an old screen, the current screen. Let's quickly check again whether this still works. All the optimizations we wanted before we can start adding game logic. Let's save this as stage 3. And let's move to the next one. Even before I wrote a single line of code, I decided to have the levels in separate files and load them up by the game engine. It feels like a crime to have the level inside the code. So stage 4 will be about adding, loading up the level from a file. I think we can achieve this very fast. So here is our game that started, and just simply copy paste what we see in the screen. Let's create a file. Let's call it level 1 and just copy paste it here. And let's take a quick look with hexdump whether I have all the characters correctly. So I have a new line at the very end. That's good. Basically, I don't care whether there is any garbage after this line, but the first several bytes that has to be correct. And yes, it looks okay. So here is a border ending, a new line, and a border starting on the new line. That seems okay, and the rest is full of spaces. Here is our level. Now let's change the code. So where do we have the board currently? It's actually here in this setup board function. And this feels like a really good place where we can add our loading code. Here we can load it up. Let me walk you through this code very quickly. So we are looking for this specific name. We open it up for reading. We handle the cases if something, for example, the file is missing. This exit will properly handle the reset terminal code, because we added at exit here. This is just a reminder. So we can call exit anytime. Okay, after that we use the fread function to read up exactly as many bytes from the file as the screens, boards are needed. And if it's not equals with it, then we also treat this as a failure. Then we call render to display the level. This is the same what we did with the setup board function. If you remember, here it is that we call the render. Now we will add something else to the state, that we have to find the player's position in this newly opened level. Let's find this. So we initialize the state with these two positions, and now we will override that with the level. We still have to write that function. I will do that in a moment. Then we, after we rendered it, we copy paste we will flip the screens. This is not needed actually, but it's fine. Then we close the file, of course. Okay, so let's locate the player. The algorithm for this is pretty simple. That what we will use, we will just iterate over all the places, and we look at whether we found an @ sign, and then we save that position. Now there is no error checking here. So if you add multiple @ signs here, then we will find the first one based on how we are traversing the space. And for the moment, that's okay. So let's assume that we have full control over the level 5s. That's our current assumption. Okay, we can get rid of these. And these. And we can see that these two will be overwritten. Okay. Before we compile it and run it, let's make some changes here to make it a bit more interesting. Let's not forget to keep the shape of the board the same. So let's create a small room here. Like this. Let's close ourselves in, and yeah, just to make some change. And now let's compile. Compiled. It's a good start. And here it is, the board that we created, and our position was correct. It picked up the position from the level itself, because we set it up to 5-5, but it was not the same in the board, in the file itself. Now what happens when we go here? Well, we clear it up, clear them up, because we have no logic for this. So the only logic we have there is in the handle player, where if the player can move and it's not in the border, so it can move there, then we will clean it up with the space. We write a space to the previous position and then write the @ sign to the new position. But still, we have what we wanted. And I think that concludes stage 4. But let's quickly copy paste the code we have. Yes, thank you.